The first bicycles in the early 1800s were made from wood. By the late 19th century, steel was widely used. Since then, advancements in technology have brought aluminium, titanium and carbon fibre to the bike industry. Developments have not stopped there, with a recent resurgence in the use of steel tubing.
The biggest change in terms of technology and manufacturing over the last 50 years has been in materials, and those influences very often come from other industries such as the motorsport industry, aviation industry. These are all areas which will use high-end materials and also manufacturing processes such as the use of carbon fibre, the use of alloys.
Steel was historically the material of choice in bicycle manufacturing due to its particular properties, with British company Reynolds being at the forefront of steel tubing design and production.
We tend to use steel on our lower end bikes because it's affordable, it's easy to build with, and it still makes a great product.
Steel frames offer us a lot of benefits in that we're using cutting edge Reynolds 953 tubing, which is super light. But great benefit with steel is safety factor, in that with steel doesn't just fail catastrophically.
You've got a very durable material, one that can be recycled, one that certainly, as far as we can see, a rider theoretically could still be riding that bike 20, 30, 40 years from now and still find the ride quality good.
When it comes to more performance-orientated products, aluminium starts to come into the field. Again, it's relatively affordable, so we can build good, lightweight bikes at good prices. It's also a material that with the new hydroforming techniques that you can build some really complex shapes.
Aluminium offered the opportunity to use much bigger tube sets for increased stiffness. It also created quite a new look for bikes.
Aluminium is one of the greatest materials to build bicycles out of. It's cheap, it's light, it's strong, and if you use it properly, you can make an absolutely fantastic bike.
We do work in aluminium, and especially alloys known as 6061 and 7005, but for Reynolds, they don't have the very high strength to weight ratio we would use for the higher end tubing that we produce for most of our customers.
Titanium is used in the aerospace, military and automotive industries to produce lightweight alloys. This low density and high strength material, comparable to steel on a stiffness to weight ratio, was introduced to the industry to build light, strong bikes with a good fatigue life.
Titanium is a really great material, really super light, but also a little bit flexy, so you don't get the stiffness, but you get a really good weight and also good durability out of it.
Titanium is one of those wonder materials that has a great ride quality to it. So does steel, but titanium bike will be probably twice as expensive, if not 3 times as expensive, and only marginally lighter. So what are the benefits to that rider in building that bike out of titanium if they can't afford it?
The techniques for welding titanium have to be actually very precise. If you don't know what you're doing with a titanium frame, you can actually have a very poor weld. So there are only a very few people who make a good titanium frame, but the cost of the material can be very, very high.
And then came carbon fibre, which has pretty much revolutionised the whole road bike industry, because that allows designers to achieve shapes and weights that was never possible with aluminium or any other material before that.
En 85, avec le groupe Tapi, on a commencé à travailler sur le carbone, et là on a fait évoluer pas mal. On a cherché dans tous les domaines pour pouvoir avoir le plus léger possible et aussi le plus performant.
Carbon fibre is in many ways the ultimate material for a performance machine. There are very few materials around at the moment which combine the same levels of strength, lightweight and versatility in terms of manufacturing. You know, if it's good enough for a Formula One car, then it's good enough for a bicycle as well.
Le meilleur de tout aujourd'hui, c'est quand même le carbone. Le carbone, c'est une matière morte, c'est du tissu avec de la résine. Et quand vous l'avez fait, il est indéformable. Vous ne pouvez pas le déformer.
Carbon, because of the flexibility it gives you a tube shapes, it means it's ideal for exploring aero designs.
The downside of carbon fibre is that it is an expensive process. It's an expensive material to work with because it's fairly labour intensive.
You feel every bump in the road on a carbon fibre bike. The steel frame is a little bit more forgiving.
In light of the disadvantages of working with carbon fibre, steel has seen a recent resurgence in bicycle manufacturing, even at a high performance level.
It's very encouraging to see steel back in the pro peloton. The UCI weight limit, 6.8 kilos for a bike, can easily be achieved with a steel bike with standard components that are around now. So the weight per se is not an issue.
In recent years, we've seen a series of dubbed super steels arrive on the scene, which offer an incredible tensile strength, which means we're able to draw the tube wall diameters very thin, so achieve weights that were previously unachievable.
What we're seeing from the likes of Reynolds and other quality tubing manufacturers is some great lightweight quality tube sets coming along. So you're seeing an increasing number of performance bikes with steel in them.
Over the years, the strength of metals has changed dramatically. Even the Reynolds 531 invented in 1935, the tensile strength there of cold work 531 was up at 750 to 800 megapascals back then. Our Reynolds 853 is up at the 1200 megapascals, and we've been doing that tube for about 15-20 years now. And when we move on to the Reynolds 953, we're looking at between 1800 and 2000 megapascals.
Material choice is a whole balance of different scenarios into what we use of material, at what price point and what bike. Price of material is probably the principal one, but then it's also what's the ride quality we want at the end of it.
Get more from the Open University. Check out the links on screen now.